So for today's lesson, what we're going to do is talk about how slope and rate of change are the same. So the slope of a line is the ratio, it's a fraction. You know rise over run already, but the rise happens to be the vertical change, right? Because vertical change means you go up and down. That's your rise. And then your horizontal change, that's your run. And that's what the rise over the run comes from. So if you're needing to find the slope, which we call m for some reason, given 2 points, you really want to find the change in the y's over the change in the x's, the vertical rise over the horizontal run. So your slope is really the change in y's over the change in x's, and change meaning difference. So the difference then of the y values and the difference of the x values. So mathematically, the slope is going to be the change in the difference between the y coordinates on top, y1 minus y2, and the x coordinates on the bottom, x1 and x2. A lot of textbooks show it to you from point 2 to point 1. It really doesn't matter the order that you go. I just tend to go from left to right, but you'll see a lot of books that'll have still the change in the y's over the change in the x's, but they'll do it as y2 minus y1, x2 minus x1. Again, it doesn't matter which formula you use as long as you are putting the y's on top no matter what, and you're consistent with the point that you start from. So what we're going to ask you to do is find the slope. So you might want to write the formula each time, or at least you put it once on your paper, and then you substitute in the x's for the x's, the y's for the y's. Make sure the x and y's are in the same order. We said that already, and you always need to simplify. Simplify means double negatives, means just if they divide evenly, if there's a number that goes into both of them evenly, etc. So again, we know that the slope is going to be the change in the y's over the change in the x's. You may or may not want to label your points. The first point has an x1 and a y1, and the second point has the x2 and the y2. So our slope is going to be the change in the y's, 2, 5, the change in the x's, -1 and 3. And then when we do the math here, extend this up a little bit, when we end up doing the math here, what's going to come out is the slope becomes -3 over -4, but double negatives must turn into positives, and our slope is 3/4. Let's take a look at the next one. Again, feel free, if you want to label the x's and the y's, x1, y1, x2, y2. I always like to put that little skeleton formula and say m equals fraction bar minus and minus, and then I dump in a 4 and a -2 and a 1 and a 3. When I do the math, double negatives happen up here. Let me just bring this down a little bit. So it turns out that the slope becomes 4 plus 2, or 6, over 1 minus 3, which is -2, and I simplify my slope into -3. Keep going. So my slope is going to be 5 minus 5, 2 minus -4. When I do the math, I'm going to get 0 over plus +6. And remember, it's okay to have 0 on the top, so the slope simplifies to just a 0. When I go for the next one, in this case, I'm going to have -2 and 3 and 4 and 4. When I do the math here, I get a -5 over 0. Remember, it's not okay, no way to have 0 on the bottom, and your slope is undefined. It doesn't work. And that's how you simplify slopes that have 0 on the top or 0 on the bottom. You should be able to be given a graph and not necessarily the points and find the slope of the line. If you look at number 1, we can test it with the points, but I'm not going to do that. I'm just going to say, you know what? I know that from left to right, this is a hill I'd be walking up. So if I take my leftmost point and I trace my path up and over, rise and run, I know that I went up 2 units and to the right 3 units to take my walk from point to point. So I rose 2 and I ran 3. Remember, slope we already said is rise over run. Here's your slope. If you look at number 2, from left to right, here's a hill I'd be going down. So I wouldn't be rising anymore, I'd be falling. But if I trace my path, my leftmost point, down and over, what ends up happening is I'm going to be going down to -2, to the right 4. This simplifies to -1/2. We wouldn't call this rise over run because it's a negative slope. I'd fall over my run. When you look at these next 2 points here, so if I'm going to try to trace my path on this horizontal line over from point to point, well, if I think about it, my slope, I didn't rise at all. I happened to run, in this case, over 6, which means anything to 0 over 6 is a slope of 0. And on this one, I don't have a left and a right point, but if I decide to go from bottom up, I happen to be here rising, in this case 4, but I don't run anywhere. 0 on the bottom, your slope is undefined. Well, it's interesting. Whoopsie. Hello. That's okay. Undefined. Let's see if I can finish up this. There we go. So what's very interesting to notice is taking a look at some of the slopes. We'll do these two right now, 3 and 4. The slopes are 0 when your line is horizontal. So the slope of a horizontal line, this is the 3rd bullet, the slope of a horizontal line is literally 0. The slope of a vertical line is undefined. Okay? The first 2 bullets happen to go back to problems number 1 and 2. If you have a positive slope like you did in number 1, a positive slope means that your line rises from left to right. We walked uphill. A negative slope means that your line falls from left to right. Okay. Just want to show you one other thing about your slopes for a second in terms of your lines. So I'm just going to come back to this new, I'm going to go to a new sheet for a second. If you remember in class, we always called horizontal lines Y lines. Remember, these are Y lines. And we also call these Y lines lazy lines because Y lines have, oh, darn it, because Y lines have a Y in them. But now we've got this letter Z also we can use because Y lines have slopes that are 0. Pretty nifty, pretty clever, I guess I'm trying to say there. If you've got vertical lines, these were those X equals lines. And if you remember, we called X lines excited lines. So we've got the X line here for excited. But if you use this letter D, excited lines have slopes that are undefined. So that might be a good trick to help you figure that stuff out. All right, so you should be good for the homework.